Hi, welcome to this lesson on measures of central tendency. In this lesson, I want to delve into the wondrous world of descriptive statistics. I will cover topics such as the mean, the median, the modus, and the normal distribution. These may sound simple at first, but there's a lot more to these statistics than you would think at first glance. They are what we statisticians call measures of central tendency. They are a single value that attempts to describe a set of data by identifying the central position within that set of data. Now, understanding these statistics is the first step in you becoming a statistical mastermind in your HR team. Let's get started. Let's say you want to make an overview of the salary of all the people in a certain department. Let's take HR. You have access to this information and create a beautiful Excel sheet that gathers all this data, showing the names, roles, seniority, and salary associated with it. It may look something like this. Lots of data, lots of numbers, but what exactly can you make of this? What insights can you gather? You may say that you now know that Joanne makes more than John, even though John has more experience. But it doesn't give you any patterns, any insights into the database as a whole. Raw data is just that. It doesn't provide insight or even a basic overview. This is where descriptive statistics come in. Let's start with the mean. We all know this statistic. It's often called the average. The mean is calculated as follows. You add up all the numbers in a dataset. In our case, the salaries of everyone in HR, and divide it by the number of data points that set was comprised of. In our case, the number of people in HR. You see the scientific notation on screen. The mean equals the sum of all the numbers divided by the number of data points. This allows us to calculate the mean, or average, salary for the HR department. Let's say you have 8 people working at HR, with the following salaries for each person: $30,000, $35,000, $27,000, $40,000, $52,000, $41,000, $88,000, and finally $55,000. If we add all these numbers, we get to $368,000. Now dividing this by 8, as there are 8 people in our HR department, we get an average salary of $46,000. The mean is probably the most used statistic out there. We hear it all the time. The average temperature on Earth is up 1 degree since the 1900s. The average person needs 7 hours of sleep a day. The mean salary in the US is $72,000, etc. The mean can also be used for age and tenure. With just the mean, you're able to get some insights in your employee data. How old is the average person in our company? And how long does the average person stay? If you're able to give one statistic on a large set of data, people often gravitate towards the mean as it gives a lot of information in just one number. It's the reason why the mean is used so much both in real life as well as HR. However, the mean can also be misleading. Despite its widespread use, it's very susceptible to something called outliers. Let me give you an example to illustrate this. We've all heard about life expectancy throughout the history, and how we used to have an average life expectancy of 35 in the Middle Ages. This has improved considerably in recent times, with an average life expectancy of around 81 in certain countries. Incredible, right? People are suddenly getting older and older. This is, however, not the case, as people got quite old during the Middle Ages as well. The only difference is that there was a high rate of child mortality before the invention of modern medicine. Because of child mortality, the average life expectancy was 35. However, if you survived your childhood, you had a good chance that you would have lived until your 60s or even older. It was definitely not as rare as one might presume from a life expectancy of 35. The same thing can happen in HR. For instance, if you want to look at tenure, HR often looks at average tenure. Let's say this is 3.5 years. However, this statistic is often skewed. It doesn't say when most people are leaving, and it might even distract you from looking in the right places. It could be that a lot of people leave right as they start, so within the first 6 to 12 months, similar to our life expectancy model. Looking at the average turnover might throw you off and make you focus on the wrong statistic, which was 3.5 years in this case. So while the mean is a good statistic to use when you want to summarize your data, it is very susceptible to the influence of outliers, or in other words, if your data isn't evenly spread, such as in our examples of life expectancy and tenure. We will talk more about outliers and spread of data later in this lesson, as well as in lesson 3. Another statistic that might help, in this case, would be the median and the mode. Let's start with the median. The median also helps us to understand the distribution of data. If we would line up all our data from smallest to largest, the median will give the value in the middle. Let's take a look at an example. We'll take age, as this is an easy statistic to work with. Here, you can see a fictional dataset from a startup with 10 people. It's a high-tech startup, and a lot of people are young professionals. Only 2 people in this company are much older, 61 and 66 in our case. If we split our dataset in 2 and look at the value in the middle, we can see that the median is 32. However, if we had calculated the mean, it would have been 42. This would not be an accurate representation of our company, as most of the employees are around 30 years old. This is the power of the median compared to the mean. By the way, if you have an even number of data points, you can't calculate the actual median, as it would fall between 2 data points. To calculate the median in this scenario, you take the mean of the middle 2 numbers. So, if the median is between 31 and 32, it would have been 31.5. Quite simple, really. Another statistic that can help us, and is often underutilized, is the mode. The mode is the value that appears most in our dataset. The mode is most often used when you're looking at nominal or categorical data. Nominal data, coming from the Latin word nomen, meaning name, represents distinctly named groups or categories. If you ask people their favorite food, and the options are either rice, pasta, or mashed potatoes, you will produce nominal or categorical data. It's impossible to create a median or mean out of this. What will be the middle between rice and pasta? The best option is to go for the option that has been chosen most often, the mode, which in this case is pasta. Furthermore, what you just saw is a form of a frequency table. A frequency table shows the number of times, or the frequency, a certain number or category shows up in our dataset. The frequency of pasta, for instance, was 16 times. Frequency tables are a great way to show the mode, but they're also great to quickly see how your data is structured. You can also turn this into a relative frequency table, which gives you the percentage in each group. All you have to do is to divide the frequency of that category by the number of data points. Multiply this by 100 or 100%, and you get the percentage of people choosing that option. A distribution can also be bimodal or multimodal. If you're looking at analyzing turnover, simply mapping the average tenure of people over the past few years can create an interesting graph. By determining the modes, in this case at 0 to 1 years, 3 to 4 years, and 7 to 8 years, you can already get some insights into the problems that people run into. A high turnover in the first year may indicate a bad selection or onboarding practices, and high turnover between 3 to 4 years may indicate low internal promotion chances. The mode is not often used, but it is useful to know about when talking about central measures of tendency. Finally, I want to touch upon the aspect of distribution, as it's an important topic when talking about the mean, median, and mode. It also helps us to decide when to use which one. A classic example of a normal distribution is height. The taller or shorter you are compared to the mean, the less likely that someone else will have the same height. A person who's over 2 meters or 6'5" is less common than someone who is 180 or 5'9", for instance. The normal distribution of height would look something like this. 50% of values would be less than the mean and 50% greater than the mean. In this case, you can use both the mean and the median as your measure of central tendency. In fact, in any symmetrical distribution, the mean, median, and mode are equal. However, the mean is often the most preferred measure of central tendency, as any change in any of the scores will affect the value of the mean. This is not the case with the median or mode. But what happens when your dataset is not normally distributed? We can have a right-skewed data, where the mean is being pushed to the right when compared to the median and the mode. This is also known as a positive skew. Remember our earlier example, where the age of 2 executives skewed the age distribution of the employees in that group. A negative skew is when the mean is being pushed to the left when compared to the median and mode. Positive skews occur much more often than negative skews, but negative skews do happen on occasion. For instance, performance reviews are often negatively skewed, which means a lot of people score good or great in their performance review, whilst far fewer people would score poorly. That's odd, as performance should have a normal distribution in an objective world, right? 50% of employees score better than the average, and 50% of employees would score less than the average. But that's not what we're seeing in the real world. The reason is that managers tend to give higher, more positive scores, and that there's no objective central point in a rating system. In these cases, the median is generally considered to be the best representative of the central location of the data. The more skewed the distribution, the greater the difference between the median and the mean, and the greater emphasis should be placed on using the median as opposed to the mean. In these cases of skewed performance, such as with performance reviews, what would be a better way to show these measures of central tendency? Take a few seconds to think about it, after which I'll give the answer. A better way to approach this problem is to show a frequency table, as you might be more interested in knowing that there are 5% bad performance in Group A compared to 10% in Group B, than knowing that the average performance is 4.2 in Group A and 4.1 in Group B. A useful technique for analyzing and visualizing skewed data would be to normalize your data. Because what should you do if you get a skewed distribution and your statistical tests require that the data is normalized? Well, in that case, you can transform your skewed data in a normally distributed dataset. Which techniques are available depend on your skewness. If you have positively skewed data, you can use the square root, the cube root, and the logarithmic transformation methods. If you have negatively skewed data, you can use the square transformation, the cube root, and the logarithmic transformation. You can perform these transformations within your statistical program of choice. These are complicated statistical techniques, so I will refer you to the reading material of this module to learn more about these. We'll talk more about variance and the spread of data in the next lesson, but first, the key takeaways of this lesson. To sum up, the mean is often used in normally distributed data and is calculated as follows. Add up all of the values in your dataset and divide this by the number of data points. The median is often used in data that is not normally distributed, such as left or right skewed data, and this is the middle number when you line up your data from smallest to largest. The mode is often used when working with data that is hard to compare with one another, or in other words, nominal data. The mode is the value that appears most frequently in our dataset. These measures of central tendency are the basis of most statistical tests and are your first step in becoming the statistical mastermind of your HR department. In our next lesson, we will continue with the variance and spread of data. See you there.